People have traditionally used 2D visualizations to represent data. These 2D visualizations, such as bars, lines, and pies, have proven perceptually effective for representing statistical data. However, when representing non-abstract data, they fail to fully convey the humanity behind the data. Personal stories, emotions, and meaning in the datasets are not effectively represented by abstract visualizations, which are often reduced to numbers and patterns. We propose that immersive 3D visualizations can be used to better humanize data and elicit consideration of the people behind the data. Our goal is to evoke an emotional connection between users and data. Rather than abbreviating data into more efficient abstractions, we utilize humane representations of data to engage users and cultivate a more personal understanding of the data. Each individual's data is represented by a single data point so that each visualization carries its own story. The collection of these visualizations enables us to view community data holistically so that individuals can see their own visualization in the context of the community they belong to. The aesthetics and design of our system combine humane representations of data with an inactive interface. This enables users to have embodied interactions with the visualizations to achieve integration between the user and the environment. We have designed a survey with questions that cover a range of topics from numerical data such as class and average social media usage to personal data including one's personality and outlook on life. The responses to our survey are compiled in a spreadsheet, which is sent to the code that inputs the responses into the virtual environment. Each person's data is visualized by an individual flower or tree, and each response is mapped to some variable in the environment. For example, a person's personality type determines the color of the flower for their visualization. This approach aims to encourage memorability of the data and evoke an emotional response from the data. We conducted a user study to test DataGarden and receive user feedback. Users became acquainted with the system and were asked to complete a set of tasks. They completed a system usability survey and participated in interviews. We received insightful feedback that we could incorporate into the system. Our updated system includes several changes based on user feedback and suggestions from the initial user study. We improved some features supporting immersive embodied interactions, such as the ability to walk, fly, and change perspectives, giving users more freedom to explore the visualizations from different angles. Some other changes include a menu that is easier to access and navigate for users who are unfamiliar with VR technology. We also included more variables and direct mappings, the ability for users to change the groupings of the flowers and trees, and adding a tooltip to foster a more interactive experience and to provide users with as much information as possible. Overall, our goal is to use innovative approaches to data visualization to foster engagement and understanding of the humanity behind the data. We now present some of DataGarden's key features.